This is lesson 5.8 on matrix multiplication, part 2. So in the last lesson, we learned a couple of quick and simple things about multiplying two matrices. The main thing that we recognized is that the only time that we can multiply two matrices is if their sizes match up just so. So when we take two matrices, matrix A and matrix B, in order to take the product AB, the number of columns that we have in A must equal the number of rows that we have in B. So we took the two sizes of our matrices, set them side by side, and if the inner pair of numbers were the same, that means that we could take their product and the size of the product would be the outer pair of numbers. Now, one consequence that we saw of this is that in general, multiplying matrices is not commutative. So in other words, A times B is not the same as B times A. It could very well be that AB exists and BA does not. So this is a big departure from multiplying scalar values. 2 times 3 was the same as 3 times 2. Now that we're dealing with matrices, that is not the case. Order does matter. Order is very important. So what we're going to look at today is actually multiplying matrices. We're going to look at some quick examples of multiplying a pair of 2 by 2 matrices, and then we'll get our feet wet with slightly larger matrices. We'll take a look at how we multiply 3 by 3 matrices, and hopefully that'll give us a better idea of how this process works in general. It is unfortunately more complicated than just multiplying two scalar values, but there is a set routine, there is a technique that we will always follow. So even though it is a little bit intense or, I'll say it, tedious, it's always the same thing. When we get to larger matrices, this is one of those things where having a computer or calculator is immensely useful. But for the 2 by 2 matrices that we're going to do by hand, it's very quick and simple. 3 by 3 takes a little bit more time, but really anything bigger than that, you're most certainly gonna want to have a calculator or computer to do it. You can do it by hand, but it's just a bit tedious. Okay, so let's take a look at this example here. We're multiplying a pair of 2 by 2 matrices. So each matrix has 2 rows and 2 columns. Okay, the way that we multiply matrices, we're going to take a row from the first matrix and a column from the second matrix. We're going to go in order. So we're going to start with this row right here and this column right here. So the way that we do this, we're going to, yellow's no good. We're going to take each of these numbers, pair them up with a number here. So we're going to go in order from left to right and top to down, or top to bottom. So left to right, so we're going to start with 3. We're going to pair it up with 4 over here. So we're going to take 3 and multiply it by -4. So the first number here, I match up the first number here. Second, I'm going to add to it the next pair of numbers in my list. So I'm going to take the next number here and pair it with the next number here. So -2 and 3 are going to be paired up. So -2 times 3. So notice here, we took the first row of the first matrix and the first column of the second matrix. So this corresponds to the row 1, column 1 entry in our product. Next, what we're going to do, we're still going to take the first row from our first matrix, but now we're going to take the second column in the second matrix. So first row, second column. And we're going to repeat this process. So once again, we take the first number here, pair it up with the first number here. So 3 times 1 plus, all right, now we take the next number along the, in order. So -2 and 2. So there we go. All right, so we have completed our first row. So to get the first row, first column entry, we took the first row from this matrix and the first column from this matrix. To get the first row second column entry, we took the first row from this matrix and the second column from this matrix. All right, next we're wanting to take the second row first column matrix. So second row first column. Let's think about this. We're going to take a row from this first matrix and a column from this second matrix. So second row first column, we'll take the second row here and the first column here. So we're going to pair things up in order once again. So the first entry here is 1. The first entry here is -4. So I'm going to take 1 times -4. Now take the next number in the list. I'm going to add that. So the next number here is 2. Next number here is 3. So 2 times 3. All right. Last but not least, I want my second row, second column entry. So I'm going to take the second row here and the second column right here. So I'm going to once again go in order, left to right, top to bottom. Take the first entry here, the first entry here. So it's going to be 1 times 1 plus, all right, second entry here times second entry here. So 2 times 2. And from here, we just multiply it out, add them together. So our final answer, we have -12 here, then -6. So we're going to have -18. Here we've got 3, -2 times 2, that will be -4. So -1. Here we have -4 plus 6. So that's going to be 2. And then 1 plus 4, that's going to be 5. So here's our final answer. So this is clearly much, much more complicated than multiplying two scalar values. That's the bad news. That's kind of the obvious bad news. The good news, though, is that we will always use this pattern to find the first row, first column entry here. Take the first row from the first matrix, second column from the first row from the first matrix, first column from the second matrix, and multiply together the corresponding entries, add all those products up. So we'll take another example, look at another example of multiplying a pair of 2x2 matrices. We'll do this one a little bit more quickly to show that we can do it within a reasonable amount of time. And then we'll move on and look at a 3x3, a pair of 3x3 matrices. A bit more time consuming, but we'll see that it involves the exact same process as what we're doing right here. So here's another one. So once again, to take the product of two matrices, we're going to take a row from the first matrix and pair it up with a column from the second matrix. So here, let's pair up row 1 with column 1. 5 times 3, that's going to be 15, plus 1 times 2, that'll be plus 2. All right. First row, second column here, take first row here, second column here, 5 times -1, that's going to be -5. 1 times 1, that'll be 1. Okay, second row, first column, take the second row from here, first column from here, -4 times 3, that will be -12, plus 2 times 2, that will be 4. And then finally, second row, second column, take the second row here, second column here, -4 times -1, that will be 4, plus 2 times 1, that will be 2. So simplify each of these entries. We have 17, -4, -8, and 6. So there's our product. So even though this is a little complicated, you can solve these quickly once you get the hang of it. So once again, take a row from the first matrix, a column from the second matrix, pair them up. We always go from left to right and top to bottom. Pair up each number, take those products, add them up. So expect to see a problem like this, maybe a couple of them even, on the drill portion. We're going to take a quick look, well, all right, it's not going to be quick, but we're going to take a look nonetheless at what happens when we take the product of two 3x3 matrices. It does require a bit more work, but it is the exact same process. All right, let's do this. So find the product of these two 3x3 matrices. This will be more involved, but the process, once again, is the exact same. So we're going to take a row from this matrix and a column from this matrix. So we're going to proceed top to bottom, left to right. So first row, first column, we take the first row here, first column here. So -1, 3, 2, we're going to match up with 2, -1, 2. So -1 times 2, that's -2, plus 3 times -1, that'll be -3, so we'll write -3, plus 2 times 2, so 4. All right, first row, second column. So we're going to take this row and this column here. So -1, 3, 2, we match up with 0, 2, 1. So -1 times 0 is 0. 3 times 2 is going to be 6. And 2 times -1 would be -2. Finally, first row, third column, we take the first row here, third column here. So -1 times -1, that will be +1, plus 3 times 0, that will be 0, plus 2 times -2, -4. All right, second row, first column, take the second row, first column. So 3 times 2 is 6, -2 times -1 will be +2, 4 times 2 will be 8. Second row, second column, 3 times 0 is 0. -2 times 2 will be -4. 4 times -1 will be -4. Finally, second row, third column, 3 times -1 will be -3. -2 times 0 will be 0. 4 times -2 will be -8. All right, last row, third row, first column. 1 times 2 is 2. 0 times -1 is 0. -1 times 2 is -2. Third row, second column. 1 times 0 is 0. 0 times 2 is 0. -1 times -1 is 1. Last but not least, third row, third column. -1 plus 0 plus 2. Grand finale, add all those up. -2 minus 3 plus 4, that will be -1. Let's see here, then this will be 4. This will be -3. We've got, let's see here, 16. -4 minus 4 will be -8. -3 minus 8, -11. 2 minus 2 will be 0. 0 plus 1 is 1. -1 plus 2 will be 1. So, a bit more involved, several more steps than with a 2x2 matrix, but once again, the same process. We take a row from the first matrix, a column from the second matrix, multiply the corresponding entries, and add those resulting products up. So, doing a 4x4, a pair of 4x4 matrices, 5x5, 50x50 matrices, you're going to follow this exact same process, but it gets to be extremely tedious. So the line that I always like to draw with mathematics is when you've got to think about something, I generally prefer folks to do it by hand. But when it becomes just an exercise in tedium, when it's just incredibly dull and boring, it's mindless, but you have to keep doing this dull stuff over and over again, that's when it's a good problem to hand over to a computer or a calculator. So for very large matrices, you're almost certainly going to handle those products with a calculator or with a computer. A 3x3 is the largest that I would ask you to do by hand, and we will only see that possibly on the application portion, when you've got a bit more time to think about things.